Come on now. Right. So, few announcements next one. So, today, obviously, we're still finishing up our introduction. Let's start on matter and energy. Second was quiz introduction. And so some lab, we're going to be doing measurement science in the morning. Now, these quizzes that I'm going to have available, they are going to count towards your grade. You will have multiple opportunities to take them. And each time you take them, they're not necessarily going to be the same questions. So they pull from a question. Now, every year I take it, and some of you believe, some of you do not do things differently. That's okay. But the purpose for these quizzes, even that I give you the quiz, is not for you to think, I'll memorize those questions. Those questions are likely going to be put into the exam. They are, but that's not the point. Okay? I want you to memorize some questions. There's nobody in there. What I'd rather you is that between now and let's say tomorrow we've done some studying over the introduction material. Look through the notes, you look through the textbook, and where there was something that you weren't quite comfortable with or understanding, you read through it. You take a quiz. And there's 20 questions. You hit a question out of those 20, and you're not really sure what it's asking. You haven't studied it. Should I take that question? Should I answer that question? No. What have you learned by trying to answer a question you're guessing at, other than frustration? Skip it. I give you multiple answers to take quiz, right? So now you finish the quiz and say you didn't answer 6 questions. And out of the 14, you got 11 right. So now you go back and you look at 3 questions you didn't get right. You go, that's what I need to study. I need to brush up on that. I wasn't sure. Okay? What about those 6? Well, now go back and I study some more. And I take the quiz again. And this time I know 18 of them. And I got 16 or 17 right. Same process again. With me. It's a gauge of what you know. How well have you been studying? What have you learned? What you still need to know? Okay? Now I can track when you take the quizzes. I can track how often you take quizzes. Trust me, there will be, unfortunately, some people who not take my advice, and the day of the exam at 12 noon, and the exam starts at 1, and there's people taking it for the first time. It's not going to help. That's telling me you haven't been studying. Does that make sense? This is a marathon. It's not a sprint. Okay? This is not high school where I know what I did in high school, and I'm sure most of you did. Night before, study an hour, go in, take the exam. Worst case scenario, you study over lunch. Even worse than that, 5 minutes walking down the hall before you turn into the classroom. Yeah, see, I know. There were those classes where you get away with it. College, no, doesn't work. I am asking an hour at most. Now, they tell me you're in class 3 hours, or that you should be studying 6 hours or so a week. It works out to an hour a day. day off, maybe Saturday, right? Relax and do whatever. Now, I know some of you are taking like 60 credit hours, and that's a lot of study time. But not every class demands. You'll work it out, what works best for you. But that's what I am recommending. Quizzes are designed as a measure of how well. Okay. Do I need to read the text? Often asked question. The text is there to help you if you're not sure. And believe me, it's a very short textbook in terms of anatomy and physiology. Printed out, it's still like that thick. It's over 7 inches. I think I so it's over 1,000. So use it to guide. Okay? Shouldn't supplement your reading, or your note taking. Shouldn't supplement or supplant rather. Should supplement your note taking. It should not supplant. Got it? Does that help? It's already been by to see me. I know that person's doing well because that person's already asked. Often, second. Okay? People come see me. Okay? Any question? So when we were together last time, we did a little bit of fun about who I am, what I do. Did a little bit of discussion about what it is to be human. We're an animal. We have a vertebral column. Mammal means that our eyes are facing forward, or rather that you have a mammary gland primates. We are the only living human. Almost everything. Just a little fun. Then we started talking about how we're going to organize our discussion about human body, but also this joint. We're going to start down here in this lower corner. Get down there with that. Little molecule. Going to move those molecules into organelles. Going to take cells. Next, tissue and organ systems, and finally, organisms. Along the way, we're always going to be referencing kind of up and down that organization chart. So we're going to always be talking, yes, about atoms and molecules, macromolecules. We're going to use those over and over and over. It's not topics that are wound up. After the first exam, do I need to know anything about carbohydrates? Absolutely. Okay, it's going to keep coming back over and over and over. Do I need to know anything about organelles? Yeah. Talk about those over and over and over. These are not just one and one problems. So up there at the top, carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphate. Those are some of the ones that are very common to the body. Or we have to talk about those, understand what the symbol means. How we're going to take those atoms and make molecules. We're going to have to talk about bonds. Okay. By the way, you know what the root word physiology is? Everybody work that out. I heard it. So we say all means a study of this. Yeah, it's not like this. But yeah, it's a study of function. All right. All right, I thought. Then we're going to talk about tissues, and those tissues our epithelial, muscle, nervous, and connective. That's all you are. Those four tissues. Those four tissue types. Now, there's a lot of variation in those, but we'll explore that later. So what is a tissue? A tissue is a similar cell that has a similar embryonic origin, as explained in that, with a specialized function. And they're collected together to do that function. So your skin is one type of tissue. Outer layer is epithelium. The epidermis. Skeletal muscle is one type of tissue. So is cardiac muscle. They're similar, but they're slightly different. Okay, so there's lots of these different tissues. Then we take those tissues and we put them together to make an organ. So your stomach has an epithelial tissue that lines it. It has smooth muscle, goes around the organ. And it has another layer of connective tissue on the outside. Three different tissues, or it's an organ. That's what an organ is. More than one tissue type, bringing common function. Process of digesting your food in the stomach, 3 different tissues together, that function. And then if we take organs that are doing a common function, process, call that an organ system. That, of course, is how we're going to study our anatomy. So, starting next week, you're going to start learning bones. After bones come muscles. After muscles comes the heart, arteries, veins, brain, nerves, respiratory system, digestive system, urinary system, reproductive systems. So, organ systems. Okay, so that's going to be our mechanism for anatomy. First along the way, already looked through the syllabus or course of study by the end of the semester. Nervous system, and we'll talk endocrine system. So we'll be doing systems before Christmas. And then, of course, we always relate it to the entire organism. So all these pieces and parts make us. How are they interrelated? Not just structurally, but functionally. So that's our organization. That's our plan of study. What we're studying. Well, so there it is again. Cute little thing, right? Playing with this apple. All right. So there's another way we can kind of organize, and that's the body plan. It's a structural plan. I had no idea that sometimes I say things and they resonate with students. I had a student walk up to me at homecoming and he said, "No, I can't." Anyway, the student walked up to me. I mean, since now he's a doctor. He said, "Can I always remember what you said on that second day in class?" I don't know. I say it every day, because he remembered from 15 years prior. So it's coming up here in a second. So the human body has a vertebral column. Remember, we're vertebrae, right? We have vertebrae. So we have this set of bones, and those set of bones are pretty much midline for everybody. Pretty much. Sometimes there's a little sway or curve to them, but pretty much right down. We call that an organizer and essential parts of the body. So from there, we can kind of look and see how things attach to it. Now, if you were a snake, it's dead easy, right? There's a right and a left on it. There's no appendages. For us, we have appendages, but guess what? Kind of attached to the vertebrae. So it's an organizer. And we'll learn when we talk about embryology. The vertebral column doesn't plan out just right. There's some things go awry. Things don't work out. Now, because it's in the center, we can also, oops, that's correct. Sorry. The next part is that you are a tube within a tube. Mouth, the anus. Goes in, comes out. Now, I know it's been modified, but it comes out, never leaves tube. There's no breaks in the tube. There's no openings. There's no places where it just whole chunks of the Chick-fil-A chicken suddenly go out into the body. Okay? It's all broken down. Pieces and parts that we want are removed. Pieces and parts we don't want stay in the tube. And then they go into the Anderson release. And around it is a tube space. We're going to look at that more. This is an intact tube within a tube. That's what my reminded me. Really? Tube within a tube? That's what you took from my class. That's what 15 said. Orthopedic surgeon is not even a gastroenterologist. It's related to this. No, that's what the vertebral column also does. Since it's in the center, you have a right and a left half. Guess what? You only need no half bottom. Because if you know the right side, then you know the left side, right? You have a right bicep brachii, then you have a left side brachii. See how that works? You don't need no 204 bump. You only need no 202 or 102. So, but it divides us. So we can do bilaterals. All right. Now, another way we look at this, and this is that tube within a tube body. You have cavities. There's the tube that your digestive system gets in. There's the mouth, and the thoracic cavity, and the abdominal cavity, and the pelvic cavity. There's space around your digestive system. These cavities are lined by what are called serous membranes. And the organs that are contained within are lined by what we call visceral. So there's a dorsal portion, posterior, and that includes the cranial cavity and the vertebral cavity. Now, brain, of course, sits in there, and this cavity is where your spinal cord is. By the way, please don't ever say you have a spine. You don't. Cerebral column, you have a spinal cord. You do not have a spine. I hope you have a spine. Metaphorically speaking, but you do not have a spine. There are spines on your vertebrae, but that's still not a spine. Okay. I digress. Now, ventral, dorsal, posterior, ventral, anterior, add a thoracic cavity. Okay, and there's going to be some pieces and parts to it called pleural pericardial mediastinum. We'll look at those in different perspectives. And then the abdominal pelvic cavity. Now, between the thoracic and the abdominal cavity, it's the diaphragm. So there is an absolute continuous barrier between those two. Diaphragm, muscle. So the thoracic cavity is separated by the diaphragm from the abdominal pelvic. Once we get down here, we just kind of, there's a landmark. It's my pelvic girdle. Everything in the side of the pelvic girdle is in the pelvis. Everything that's superior to my pelvic girdle and inferior to my diaphragm, that's the abdomen. no barrier. And that's a good thing. Gentlemen, we're not as concerned about it, but females in the room are very glad there's no barrier when they get pregnant. The baby's got to go somewhere with a barrier. So it's more of a where is it kind of thing instead of a barrier. All right. So you look at this again in a different way than dorsal. Cranium, T-hole. Cranial, brain. Hebral, spinal, thoracic cavity. Right? So we're looking at it in the anterior, and we see the two pleural cavities. We're in the pleural cavity. What's in there? So plural, referring to lungs. Pericardium. It's in there. Heart. Cardial refers to heart. How would you? Technical terminology. So it comes along the way. Well, yeah. Mediastinum. Media. Middle. It's just the face. Now there's some important things in there. The aorta, European cava, trachea, esophagus, and those are kind of important. But there's not really a space. It's just kind of an area. There's diaphragm, there's our abdominal cavity, and there's pelvic cavity. So just a lot of pictures. Now I said a cavity is formed by two membranes. We call serous membranes. One is called the parietal serous, the other is the visceral. Term serosa or fluid, referring to fluid. Fluid in there. There's also an organ. How many deer hunters do I have? Just one? Oh, two. There. Okay. Oh. That's a first. Okay. How many fisher persons do I have? All right. There's duck hunters. A lot of guns down here. Stay away. Every time you go out and shoot, don't hold them tired. Got it. Take a knife, slip down to the abdomen. Will you pull out? Guts. Another word for guts. Viscera. You eviscerate. Yeah. You remove the organ. Why is it viscera? That's the membrane. It's the membrane on the surface of the organ. Heart has a visceral membrane. Your lungs have visceral membranes on them. Your abdomen, your digestive system have visceral membranes on them. That's why when you open a fish or a duck or a deer or cow, pig, whatever you're dissecting, they look shiny. They have a membrane on them. And you also know, those of you gutted animals, when you slit them, fluid pours out. Fluid inside, cavity. It's the serosa type. Now, the cavity is formed by the parietal cushion. That's the lining of the cavity. So if I slit my abdomen, open it up, you look inside, there's another membrane there that's shiny. It's parietal. Then there's the face, and I find my large and small intestine. There's a membrane on it. It's the visceral. Between is a space. So our heart is, of course, the organ. Around the heart is the membrane, visceral. And to form the cavity where the heart is, it's the parietal. Whoa. So two membranes and in between a space, fluid. You'll find that everywhere that we just talked about. So this is the verbiage what we were talking about. So the first cavity, this cavity that's filled with fluid, is formed by two membranes. Parietal is the outer wall. And the visceral is on the surface of the organ. In between is a space that's filled with fluid. So, pericardium is where the heart is. Parietal pericardium, visceral pericardium. Pleural, where the lung is. Parietal and visceral pleural. Parietal peritoneum, the abdomen. Visceral peritoneum on the stomach, large, small intestines, etc., etc. I'll know that because I know that you do that or feel things sloshing around. Good side. Yeah. All now, the same thing applies to the dorsal. We're going to find there are membranes around the brain and spinal. I'm going to call them a little differently, but they're there. All right. So, a little picture of where the heart is located. Membrane skin was for, surface of the heart. Parietal forming the cavity, fluid in the middle. Abdomen, same idea. Fluid. Parietal. And this one. And another one. Lots of fluid. Yeah. All those membranes. Parietal forms cavity. Walls. Visceral on the surface of the organ. Okay, so that's our introduction. Let's skip the slide. If you're playing along with it, that means that I felt it not important. How many have had some chemistry at some point in their life? Oh, so good. I'll make my organic chemist. So now we're going to switch and start talking about matter and energy. Matter. Matter matters. Joe, matter matters, right? How many forms of matter are there? 3, 2, 4. Let's say 3. 3 forms of matter. Yeah? What else? Solid, liquid, and gas. Who wants to say there's 2? Who wants to say there's 4? What's the 4th? Yeah, yeah, it is, but it's this weird thing that most of us will never, ever encounter. I don't plan on going to the sun anytime soon. So, solid, liquids, gases. We're going to restrict our thinking. Matter, by definition, anything that occupies space and has mass. I can get behind that first part. Anything that occupies space. This is a space that's filled with something and it's matter. Air, right? I'm solid, therefore I have matter. Okay? Helium should have water in it, so it should be liquid. Solid, liquid, and gases. Mass is not even weight. Sometimes we think they do. So, mass is simply the amount of matter. Not how much you weigh. Weight is gravity, pulling on the mass. So, I always want to go to the moon. What I weigh here, I suddenly lost a lot of weight when I get to the moon. Okay? But my mass is still the same. So really, when you lose weight, you don't lose weight, you lose mass. There'll be a whole new trend out there. Mass loss, weight loss, right? I'm going to teach a program on mass loss. So it has mass. Okay? Well, what is this mass made of? What is this matter? Made of elements. Elements are the simplest form of matter. In other words, they cannot be subdivided. Now, there are little building blocks, little elements, but you cannot break hydrogen down into anything else. You cannot break oxygen down into anything else. It's oxygen, it is hydrogen, carbon, etc. Simplest form. How many of them are there? There are 92. Some of which are very rare, and some of which are very, very, very abundant. Your air is actually more nitrogen than it is oxygen. Every element has a unique chemical property, what sets it apart from all the others. Carbon behaves differently than oxygen, behaves differently than sulfur. Okay. We'll talk more about that in a second. There's about 24 of them that we're really worrying about, and notice I did not write them up there. So therefore what? So if you see that, it just runs here. I get it. Okay, but it's just there for illustration purposes. There's number 92. Uranium. Everything from uranium down to hydrogen. Those are the naturally occurring. Well, what are all these things after it? Well, neptunium, polonium, yeah, those were made in nuclear reactors. They aren't natural. Okay. Man-made. Human. So hydrogen is down to 3. Now, every single one of these has a set of numbers that go with it. One up there is telling you the numbers. We'll get to that in a second. So, every element has an atom. Every atom has a nucleus. An atom is the smallest unit of an element. Every element is made of atoms. Every atom is a nucleus. The nucleus is made of protons and neutrons. And proton plus neutron is the atomic mass. In other words, that would occupy space. Remember, matter is anything that occupies space and has mass. So the atomic mass is the matter that's occupying space. It's made up of protons and neutrons. Number of protons equals atomic number. So, uranium is 92. How many protons does it have? 32. Hydrogen has an atomic number of 1. Protons. 1. Etc. Electrons are outside of nucleus. And they occupy what are called energy levels. That is all I'm going to say about that. Okay, I'm not going to ask you about P and Q orbitals, which direction you spin, and all the rest of that stuff. Only one thing about electrons in it. Now, you probably already noticed this. Those of you up front, this little line there. Some of these little subatomic particles, protons, neutrons, and electrons, have charges in them, electrical charges. What is the electrical charge of a proton?
Positive.
There's a positive charge. Electrons carry
Negative.
negative charge. And neutrons are a dead easy one because neutron means neutral. No, sorry. Now, if you want to lie awake at night and think about something that's kind of incomprehensible, those are positive charges in there, no charges in there, and we always know that they should repel each other because we have positive charges should make each other. One of those things we have yet to figure out. Okay. So, atomic number. Proton plus. Atomic mass is proton plus. Neutron. If I have 12 protons, how many electrons should I have? If I have 12 protons, how many electrons should I have? 12. Well, okay. Why? The number of protons should equal the number of electrons in an atom because they have a charge of 0. They're neutral. So if I have a positive charge, I need a negative charge. Now, yeah, those up front here, you can see this a little easier. 6 protons, 6 electrons, 6 neutrons. 19 protons in potassium, 19 electrons in potassium, 20 neutrons. 20? Shouldn't there be 19? No. Okay, everything's got its own unique chemical property, and it has its own unique chemical mass. Atoms will vary in the number of neutrons. Okay, it does not happen. We'll have some examples. So, these are 3 examples of hydrogen. Hydrogen is atomic number 1. We know that it should have 1 proton. And therefore it should have 1 electron. Right? 1 proton, 1 electron, positive, negative, 0. But this is the most common form of the hydrogen atom. There are no neutrons in it. So what's its atomic mass? one proton. But there are other forms of hydrogen where there's a proton and a neutron. And there's others where there's a proton and two neutrons. So 1 plus 1 equals an atomic mass of 2. 1 plus 2 equals an atomic mass of 3. These, when combined with oxygen, form something called heavy water. If you've been to see Oppenheimer, you probably heard it. That's what they need when they reaction. So, an isotope is when there is a different number of neutrons. So, question: a different number of neutrons is different. Atomic number or atomic mass? What changes? What is different? Atomic number or the atomic mass? And more or less. Atomic mass. So why is there no different chemical behavior? Different isotopes, same element. 3 different forms of hydrogen. All of them can be found in water. H2O. So what didn't change?
The
neutrons changed. What didn't change? Number of protons and
electron.
Our purpose is electrons. I'll tell the kids that. Big philosophy. It's electrons mostly. They did not change. 1, 1, 1. So they are chemically the same. Now, watch what happens if we change something else. We just played around with neutrons and made isotopes. By the way, isotopes do have medical uses. If you get diagnosed, unfortunately, with, say, a tumor of your thyroid gland, it can give you an isotope of iodine. And that iodine will go to the thyroid gland and destroy it. Because it added radioactivity. Not enough to kill you, not enough to do anything else, but it'll take care of the thyroid. We inject isotopes into your blood so we can trace blood flow. You swallow barium. Oh, yes. To see what happens in your digestive system. Isotopes, they do have medical. All right. Ions are charged atoms. Remember, so far, an atom is 0 in terms of charge. It is neutral. I have 1 proton, I have 1 electron. I have 32 protons, I have electrons. Okay. So these are charged. They have different numbers of protons and electrons. Now, which is more likely to change in number, protons or the electron? The electron. Why? Yeah, don't give me the big chemical. Just go simple up. Why would it be easier to change the number of electrons? Thank you. They are outside the nucleus. They're outside the nucleus. They're just like little bees. Just around out here. Whee! One flies away. It's a heck of a lot easier for that than one of these inside of this and walk. So we get rid of or add electrons. Now, this is sodium, this is chlorine. Now, again, I don't care about energy levels, but notice this outer ring here has 1 electron. This outer ring has 1, 2, 3, 4, 5, 6, 7. 8 is the magic number. If that chlorine atom can gain that electron, and notice there's 1 there, it goes away. 1, 5, 6, 7, 8. Sodium, really happy. It only has 8 in its outer shell. That's it. 8's a good number. So it's stable. So this electron is given away to chlorine. And now this is charged because it has lost an electron. How many protons? 10 electrons. So it is a positively charged ion, right? Positive 1. 11 minus 10. 1. And over here, it gained an electron. So it had 18 electrons versus 17 protons. 1 more negative charge. So it's negative. Cool. And we changed the name to chloride. Don't ask me why. And this, positive, negative. Do they like each other or do they repel each other? They hate each other. Oh, positive and negative. They don't repel, they opposites attract. You gotta have some difference in a relationship that saying the opposites of each other. So they come together. And voila, you have salt. Go to the marketplace and shake a little salt on the cake because they got food. That's it, salt. And that process of adding an electron and losing is called ionization. Adding or losing an electron makes an ion. The process is called ionization. Now, 2 important things about ionization. We have 2 minutes. 2 important things about ionization. It has to occur in water. It has to occur in water. If I have sodium sitting on a table with chlorine gas floating around it, not get ionization. I have to have it in water. It has to occur in water. Now, the second important thing, yes, that's the second important thing, is that in biology, actually in human anatomy, you call them electrolytes. You got the Gatorade. Nobody? Propel bottles? Nobody? Oh, nobody's drinking anything with electrolytes in it today? Oh, just got you. Look at all those bottles. It's got electrolytes written on it, right? All it means is it has ions that are important. And ions conduct electricity. That's the second key. Occurs in water, makes them conduct electricity. We are going to use those so many times, you're going to be sick of me talking. They're valid. All right, if you're in lab today, I'll see you.